I decided to divide the 9.7 video into 3 parts, just so they're 3 shorter parts. Okay, so this is part 2. Okay, so this is 9.7, part 2. Okay, and these next 2 parts have to do with solving a triangle. If you remember from section 9.6, if I have a right triangle, let's go triangle ABC. To solve this, I need to find all the missing pieces, all the missing sides, all the missing angles. And to do that, we tended to use that whole SOHCAHTOA idea. Okay, but can we solve a triangle that is not right? Okay, and we actually have a special word for not right. We call it oblique. That's a Q. Oblique is what we call a triangle that is not right. And yes, we can, but you can't use SOHCAHTOA. Yes, but can't, I'm putting it in bold, use SOHCAHTOA. SOHCAHTOA only works in a right triangle. Okay, so that's a bit of word of caution here. Yes, we can solve an oblique triangle, but you can't use SOHCAHTOA. Instead, we use something called the law of sines. Okay, so what the law of sines tells me, in any triangle, okay, in any triangle, this is for any triangle, okay, the ratio of the side lengths to the sine of its opposite angle are always equal. So the ratio of side A to the sine of A is going to be the same as side B to the sine of angle B, side C to the side of angle C. So we can set up these proportions. They are proportional. Okay, so if you know, okay, so you need to know, if you know one side and its opposite angle, then you can set up a problem using law of sines. So you need to know one side and its opposite angle, and then one other bit of information. You can use the law of sines. Okay, so I need to know a side and its opposite angle. And again, you can see here how we can put the sine on top, the side on the other side, or we can flip-flop them. It doesn't matter. The proportion will be the same. It's kind of like saying, well, 1/2, if 1/2 equals 1/2, well, that's the same as saying 2/1 equals 2/1. Okay, it'll work out the same depending on which way you write it. Okay, so we need to know a side and its opposite angle. So sometimes it's helpful for me to label. Here, I know this side 36, this opposite angle is 70. Okay, so I'm kind of going to highlight there. So we know the side of 36, the opposite angle is 70. Here we know the side of 18, the opposite angle is R. We don't know that angle. Okay, and then last we'll use green. So here we have P, the angle there is P. Okay, so we need to find, to solve this triangle, we have some missing pieces. Things we need to find. We need to find the measure of angle R equals something. We need to find the measure of angle P equals something. And we need to find the side lowercase p, or I'm going to write it as side R to Q. We need to find the distance from R to Q. Okay, so we have those 3 different pieces, but if I know angle R, then I could find P, because all the angles add up to 180 in any triangle. So I'm going to find angle R first. So we know the side we know orange, 36 and 70. So if I put, again, there's a lot of different ways you could set this up, but if I do the ratio of 36 over the sine of 70 degrees. So there we're doing orange right there. 36 over the sine of 70 degrees. That has to be equal to, okay, we're finding purple here. We're going to find R first. Okay, that would be equal to, we did side over angle. So now we have to do side over angle. The purple side is 18 over the sine of angle R, which we don't know what the sine of angle R is. That's what we're trying to find. So we did side over angle equals side over angle. So we basically set up our ratio. Both of these could be flip-flopped. Okay, and we can't actually solve for P first because we don't know the green side. Okay, so we can't solve for this yet. So now we use our means extreme. So I'm going to take the 36 times the sine of r, which we don't know what that is, equals 18 times the sine of 70. Well, we know what the sine of 70 degrees is. Okay. And so now here to get the r by itself, it's the sine of r. To get the r by itself, we have 36 times the sine of r. I'm going to divide both sides by 36. Okay. I'm going to show you a new button in your calculator because we have 18 times the sine of 70 divided by 36. So I'm going to get a decimal approximation for that. We have 18 times the sine of 70. I'm going to put enter on that, divide by 36, and we get 0.46. So r is approximately 0.4698. The sine of r, excuse me, is approximately that. To prevent rounding errors, what I'm going to do is I'm going to actually store this number in my calculator. So the store button is right here above on. Do you see on? There's that STO. So there's the number I want to store. It was the last thing entered. I'm going to hit this STO button. Do you see it says answer arrow? So answer store. And I'm going to store it as any one of these green letters. I always go A because the alpha button, to get to the green letters, you have to hit the alpha button first. And alpha and A are right next to each other, so I'm going to go alpha A. Okay, so I'm going to store that answer. This answer is alpha A, so I'm going to hit enter. So, see, we got that same answer again, but look what happens if I just type in alpha A. I always get that 0.469846, no rounding. Okay, so now I have it in there, so I can use it wherever I want. Okay, whenever I need that number, I can just type in alpha A. Okay, so if the sine of r equals 0.4698, r then is going to equal the sine inverse. Remember this from the last section? To find the angle, we're looking for the angle that has a sine of 0.4698. So I'm going to do the sine inverse of 0.4698. So now I just hit my sine inverse button, second sine, alpha A, so no rounding involved, and I get 28.0. It says round to the nearest tenth, so r is approximately 28.0 degrees. Okay, so we found the measure of angle r. So I'm going to put that in my picture, 28.0 degrees. Well, now we can find the measure of angle P. Because the measure of angle P, I'll need to take 180 minus the 70 minus the 28. Because all the angles in a triangle that have 180 minus 70 minus the 28. So measure of angle P is 82 degrees. That's this one. Well, now that we know that the measure of angle P is 82 degrees, we can find P. Be careful, you cannot use the Pythagorean theorem here because it's not a right triangle. Okay, so you can't use the Pythagorean theorem. It's not right. Okay, so to find this distance from r to q, this lowercase p, again, we set up here our law of sines. So we have green angle over green side. So I'm going to do it the other way around, the sine of 82 over p equals, now let's use the orange again because that's the one they give you, the sine of 70 over 36. You see I set this one up upside different than that one? Again, it doesn't matter because once you means extremes it doesn't matter. So as long as you have them both consistent, angle over side, or side over angle, side over angle. Okay. So now we means extremes it. So I'm going to take 36 times the sine of 82 equals p times the sine of 70. Again, the sine of 70 here is just a number. So I have p times a number. So to get p by itself, I need to divide both sides. Ooh, running out of room by the sine of 70. Okay, so those will divide out. So p is going to be approximately, so I'm going to need to take 36 times the sine of 82. I'm going to hit enter on that and then divide it by the sine of 70. So p is approximately 37. If we go to the 10th place, 9. So r to q is approximately 37.9. So we now found all the missing pieces. We found the two missing angles and this one missing side in an oblique triangle. Okay. All right, so here we have another one. Solve the triangle, round decimal answers to the nearest tenth. Again, we want to solve this. Okay. This one, let's see. Oh, this is side A. It was missing. Okay. So we know angle A. We know side A. Again, highlighting helps. Here's angle A. Here's side A. Okay. So we're missing one angle. We're missing the measure of angle B. We don't know that one. We don't know side B, lowercase b, and we don't know side C, lowercase c. But since we know two angles, we're missing the third. We can find that one just by subtracting from 180, because all the angles add up to 180. So we'll go 180 minus 115 minus 38. We get 27 degrees. So we know the measure of angle B now is 27 degrees. So I'm going to put that in my picture. Okay, 27 degrees. So now you kind of pick which one do we want to solve for next. Now that we know angle B, we could find side B. Okay, so again, we set up our ratio. We'd have 38 degrees. So the sine of 38 degrees over opposite side, 25, equals, we did degrees over side, so we have to do the same here, the sine of 27 degrees over B. Now we means extremes it, so I'd have B times the sine of 38 equals 25 times the sine of 27. So again, the sine of 38 is just a number, so I'm going to divide both sides by that. Do you notice how I don't round that in there? The more often you round, the more inaccurate your answer is. Okay, so to get rid of a multiply by sine of 38, I divide. So B, lowercase b, would be approximately 25 times the sine of 27, enter, divided by the sine of 38. We get 18.4. B is approximately 18.4. So I'm going to put that up there. Now we just need to find C. We're going to do that exact same process to find C. So we would take the sine of the 38 divided by 25 equals, now angle C is 115 divided by side C. Again, means extremes. C times the sine of 38 equals 25 times the sine of 115. Now I'd have to get C by itself, I'd have to divide both sides by the sine of 38. So C is approximately 25 times the sine of 115 divided by the sine of 38. We get 36.8. Okay. So there are my three missing pieces. Okay. All right. Okay, we're going to skip example 5. I think you're good without it. Okay. We have one more thing to talk about, the law of cosine, so stay tuned for part 3.